For this recording, I wanted to go over an equation that is not on the formula chart, and that's because the equation's so simple, you're kind of expected to know it. And that's this equation in the top left. And I refer to it as the average velocity equation. And, excuse me, if you recall, we can find average velocity by taking the total displacement over the total time. Okay. So if we look at the equation in the top left, it looks like it's this equation that's been rearranged, but this doesn't match. Well, take the graph that I've drawn for us. Let's say we started out at some velocity and accelerated to some new velocity in that time interval. The area underneath the curve, or the area underneath this line, represents our displacement. Well, if you remember anything from geometry, hopefully it's that if we have a line going from one corner of the rectangle to the opposing corner, it's that these two areas are the same. So that line right here that represents our motion would give us the same area as if we had taken a line going right down the middle. So this is halfway between our two velocities, which we can find by just taking the average of the two velocities. We can only do this because the acceleration is uniform. And that's true with all the kinematics equations I've shown you. They all assume what we call uniform acceleration. We say uniform because we want to take it beyond a constant acceleration. It's not just the fact that the object is accelerating the whole time, it's that the acceleration, that rate at which the velocity is changing, is consistent that entire time as well. So the magnitude is not changing, and neither is the direction of the acceleration. So essentially we have traded 1/2 of that area for another half. So we've cut that part out to give us the same area. So we're swapping this for the average of our final and our initial velocity. And that's where this equation comes from. So it's just your average velocity equation rewritten. You'll notice it's the only kinematics equation that doesn't use acceleration because we don't need the slope of this line. We don't really care since we know that whatever area that line creates, it'll just be equal to that halfway mark. Again, assuming our acceleration is uniform. And that's all I got. So make sure to have this one memorized.